C-Voice Wrap-Up, the complete voice-over IP network design. Well, we've talked about a lot of stuff up to this point in the series. And it may seem, if you're anything like me, the first time I saw voice over IP, it seemed like just a bunch of disjointed concepts. Like you had these analog interfaces, and they did certain things, and digital connections, and they had certain configurations. Then there's these protocols somewhere in the mix, H323 and SIP, and where do these fit in the picture? And then on top of it all, you have the voice routing table with dial peers, different wildcards, different matching scenarios. I mean, it just seemed like a bunch of disjointed stuff. And what I wanted to do was create just one video that ties it all together. Takes all the concepts that we've seen in the series and puts it into a practical, real-world situation. So here's the story. We have this router that's at our office in the middle of everything that has two analog connections to these FXS ports. These are going to be just end-user phones that are tied together into a voice-over IP network. Now it connects to a remote office over the IP wide area network and also across the PSTN as a backup connection. That remote office is connected to an existing PBX system that has extensions 45XX, anything beginning with 45 over here. Now at our office, we also have a PBX that's currently in place, and this is what most of our users are running on right now, that use extensions 43XX. Attached to that PBX system is an interactive voice response system, an IVR system, that handles incoming calls. It's kind of like our automated attendant. It directs people to the correct locations and correct extensions, allows dial by name and dial by extension systems, and also ties together into a SQL database that can read people their bank account balance or, integrate with a group of receptionists and distribute calls correctly. So we have this extension that is assigned 4300 that should respond to all incoming calls. Now that's tied into the story using a T1 CAS digital connection, and our PSTN connection is just a group of two FXO ports. So our goal is to set it all up, to make a real-world story here out of all these disjointed concepts and build a voice-over IP network in a single scenario. Now, we don't have the time to set up the other office as well and really tie everything together, but I think just by seeing a single router, a single office setup, it will really help all these concepts tie together into one congruent story. Before we begin, let's take a look at the necessary facts that we need to configure this scenario. First off, the remote site has a direct inward dial DID range of 480.612.45XX. So when we look back at that remote site, we should be able to implement some kind of PSTN failover using that range to dial into that network. However, our local site has no DID number since it only has two FXO port connections. It will just have the incoming number of whatever those FXO ports are. The calls should prefer to use the wide area network connections if available. Good to know. Voice over IP should be prioritized for up to 450 kilobits of WAN bandwidth. The local PBX should trunk using T1 CAS FXO ground start signaling. I'm sure we'll come back to those facts plenty of times, but I'm ready to get going with the configuration. Me being the slacker that I am, I would prefer to go for the FXS ports first because those are the easiest. And that'll also let us get familiar with our router as well, just verifying the voice ports that we have available. I'm going to go ahead and do a show voice port summary. And we have our FXS. There's our two FXS ports installed in there. It's in the chassis, module 0 of the chassis, port 0 and 1. We have our FXO ports, 4 of them. It looks like from the diagram we'll only be using 2 of those 4. The T1 CAS connection we can only see doing a show controllers T1. And there's our T1 0/1/0 currently down. We haven't provisioned it at all or assigned a DS0 group, so it looks like just about everything is as it should be. Like I said, let's start off with those FXS ports. Go into global config mode, and I'll do a show dial peer voice summary. Of course, preface that with the do command. And it looks like we have just the base dial peers that we need for our phones themselves, the IP phones that are managed by this Call Manager Express system, and then a couple POTS dial peers that are going again out to those phones. So it looks like just Call Manager Express configuration has been set up so far. So what I'm going to do to set up those FXS ports is just do a dial peer voice, and we'll say this is, let's go ahead and use the numbers that are shown right up there in the diagram, 3101, and that will be a POTS dial peer, plain old telephone service. And we'll say a destination pattern of 3101. That's our first phone extension. Now remember, with a POTS dial peer, any explicitly defined number is automatically stripped before it's sent out to that line. But with an end phone, we don't really care. The phone doesn't need to know its own phone number. It just needs to know when somebody calls the number to ring. That's all the FXS port will do, is send an electrical ring signal out to that phone. So I'm going to say the correct port that one's connected to. Let's look at our diagram. It's FXS 0/0/0. So we'll go ahead and just do a port 0/0/0. Good. Now let's go ahead and do a dial peer voice for the other one, 3102. Same commands, 3102 destination pattern, and port 0/0/1 on that port number. So now we've got our two FXS ports configured. Cool. Check that off our list. Let's see, what's next? Well, the WAN, that's going to be a whole nother story. Let's get this T1 CAS connection going. If I remember our facts correctly, and let me get those right back in the middle of the screen, our facts show that the local PBX should trunk using T1 CAS FXO ground start signaling. So, let's go ahead and get that trunk running. Shows that our T1 connection is 0/1/0, coming right out there. I'm going to type in controller T1 0/1/0. Now, when I hit the question mark, if it was T1 CCS, I would go ahead and use the PRI group to configure it, because that most likely would be a PRI setting where there's a separate signaling channel. But T1 CAS includes the signaling with the channels. So I'll use the DS0 group. You can see it's a replacement of CAS group, which was the old command. So I'll type in DS0 group, followed by my group number. I usually just use group number 0. It's the first number in that list. And remember, this group number is just a logical identifier for that whole group of time slots that I'm about to configure. Now, unfortunately, my router only has enough resources to do 2 of these time slots, because I have it stocked full of FXO, FXS. It doesn't have all the DSP resources. So I'm going to go ahead and do just 1 through 2 as the time slots that I plan on using. Now, if I hit enter, it will just use blank signaling. You need to specify a type of signaling, since we're going to be using this for our voice channels. Now, if I remember the facts correct, it said it should be using FXO ground start signaling. Go back to our signaling here, FXO ground start. Now remember, the PSTN typically uses FXO loop start because it's connected to the loop of phones. Hit the question mark and it shows that I have nothing but an enter to press. So I go ahead and press that enter key. And at this point, I should be able to go back here and do a show voice port summary, and I now have the 2 FXO ports configured in my list. FXO ground start, channel 1 and channel 2, both of them currently idle and on hook. Good. So that's set up. Our T1 line is now running to the PBX, but we need to configure a dial peer for both those extensions. Now, all those extensions, 43XX. Now, just because we're running a digital connection doesn't mean we're using some kind of voice over IP dial peer. This is still POTS, because POTS encompasses any legacy technology, and that, a PBX, is legacy. So we'll go ahead and do dial peer voice, and I'll go ahead and use a tag of, let's do 4300 just to identify it. Anything with 43. Now I'll identify that as a POTS dial peer. And under the POTS dial peer, I will say that this encompasses the destination pattern of 43 ... anything starting with 43. Now, since this is POTS, It's going to hose us up because it's going to strip 43 and just send whatever the ... is because of the auto strip feature. So what I'm going to do is I'm just going to type in no digit strip because it's okay to send all of the digits to that PBX. The PBX needs those digits to figure out what phone to forward it to, and since the PBX uses 4-digit extensions, you know the rest of the story. So I'm turning off the auto digit strip feature by doing that, and now I need to say that I'm going to forward this out. Let's go ahead and type in port. I'll just use the good old copy paste right here. This is our port, 0/1/0:0. That's our DS0 group, is the colon. Type that in, hit enter, and we are now configured to send anything with 43 ... out those ports. Let's just verify our config. Show dial peer voice summary. Good. So we now have our 2 POTS dial peers configured to go out the correct FXS ports over here, 0/0/0 and 0/0/1. That's our 2 phones attached above. And then I have our 4300 dial peer for this destination pattern to go out this individual port. Now it's showing down just because my T1 line isn't really connected to a PBX. Fortunately, I don't have one of those sitting by my side. But if it did, the line would go up, the T1 line would be up, and it would show that the outbound status would be up on that dial peer. So at this point in time, we now have the PBX extensions. It's configured to route out the digital line for that. Our 2 FXS ports. So let me just refresh the screen real quick so I can get that white line out of my FXS. There we go. And now let's go ahead and configure this router for outbound PSTN calls. All of my outbound PSTN calls are going to go out these 2 FXO ports. So I need to configure it in a redundant configuration to where it will use the first FXO port, but if that one's busy or maybe just unplugged, it will fail over to the second FXO port. Let's go ahead and bring up that config. Get into global config mode, and for now let's just go ahead and do local 10-digit and long distance dialing. Just because the local 10-digit dialing and then the long distance 11-digit dialing. If you don't have 10-digit dialing, it gets even easier because you only need to do a 7-digit extension dial peer. We'll worry about international later. I'll go ahead and do dial peer voice and use a tag, and let's just, looking at all my tags up here, might as well for the PSTN dial peers, let's go ahead and use the 100 series. And that'll be a POTS dial peer. From there, I will do the destination pattern of, let's do long distance first. That's easy. We'll do 9 for an outside dial tone, 1 for the long distance code, ... There's our 3-digit area code, ... Our 3-digit prefix, ... Our 4-digit local area code. Now, if you're out of the country and you're watching this, this is just for the United States. You'll have to tweak this to modify it to be for your own location. But this is now my long distance dialing code. But I wanted to strip the 9, the outside access, but I don't want it to strip that 1. So instead of saying no digit strip, I'm going to say forward digits, and we'll do, hang on, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11-digit dialing for our long distance code. So I'll forward 11 digits, strip that 12th, that 9th, out port 0/2/0. That's our FXO port. Good. So now we have our first dial peer configured. Let's add in our second one for the 10-digit dialing. And I'll do destination pattern. And we'll do 9 and bracket anything but 1 for the first digit. That's pretty much saying if I dial a 1, it rules out this dial peer and goes over to this other one. Anything but 1 will be this one. And 10-digit dialing, so that's our first digit. 2, 3, that's our area code. 3 for our prefix. 4 for our just local zone area. So now we've got that configured correctly for our 10-digit dialing. So that gives us our PSTN dialing peers. And you know what? Why not? Let's add in something for international. I'll do dial peer voice 102 POTS. Oh, hang on. Let me jump back under 101 because I forgot to put the port. 0/2/0. And let's do the 4 digits on that of 10, because that is a 10-digit number, and we'll strip off that 9. Can't forget to do that, eh? And then I'll come down here, dial up here 102 pots, and let's do destination pattern. For international dialing, let's just do .t, which is pretty much, well, let's do a 9T. That'll be a little easier. An outside access code needs to be dialed, and then any digit beyond that. Remember, the most specific matching rule will take effect. These two will match before this one does, so any other one will go ahead and go international. So we'll say destination pattern 9T. We'll go out port 0/2/0. Let's see. For the digit strip, how are we going to do that? Oh! Duh. This will be stripped automatically. Why? Because this is an explicitly defined 9 on this POTS dial up here. So we don't need to worry about digit strip. The T is a wildcard. Those will forward. The 9 is automatically stripped because it's explicitly specified. Good. Now, we've got, let me do a show dial up here, voice summary. We've got our 3 dial pairs pointing out the FXO port connected to the PSTN. Now let's make it redundant, and this is where our friend Notepad will come into effect. I'll do a show running config. Get down here. Scroll, scroll, scroll. There we go. Right here to the 101, 100, 101, and 102. Go ahead and do an Alt-C. I'm in TerraTerm, so it's not Control-C. I'll do a Notepad. Bring Notepad into the mix. Paste. Let's do, this will be 103, 104, 105. Use the same destination patterns, but point them out FXO 0/2/1. So go ahead and bring that back up. And got those next 3, same 4 digits. 1, 1, 1. And now we'll add in preference 1 to every single one of these. So it's no longer the preferred one, but if the other one is busy for some reason, this one will fail over. It gives us the use of up to 2 FXO ports for outbound dialing. Copy that back into my buffer. Go back into global config mode and paste away. We've now pasted all those in there. I should be able to do that show dial peer voice summary. And now we have the redundant set of dial peers with exactly the same configuration for the second FXO port in our mix. So same digit stripping, same everything. It's just this is a preference of 1, so that second FXO port will be used just that second. So now we've got our outbound dialing calling for the FXO ports. We've got our PBX extension set up. Let's go ahead and set up inbound calls. So when somebody dials inbound, remember this was from our fax list, when somebody dials inbound from the PSTN, our local site has no DID numbers, so it should just forward them over to the IVR system. To configure that forwarding, I'm going to jump under the FXO ports and set them up. I'm going to go into global config mode, and let's do voice port FXO. Oh, what am I thinking? FXO. It's 0/2/0 is the first FXO port. We're now under that configuration mode. And I'm going to type in connection, followed by what kind of connection I want. Now remember, PLAR is the bat phone mode, meaning as soon as it goes off hook, it will dial inbound. I'm going to go ahead and type in connection PLAR, so as soon as that FXO port receives an incoming call, it's going to dial, and I'll go ahead and put the extension number, the IVR system, 4300. But I'm going to add on here OPX. I'll explain that as soon as I type in 4300. OPX stands for off-premise extension. What this is typically used for is when this goes off hook. First off, let me describe what PLAR does. Connection PLAR 4300 will, as soon as it goes off hook, immediately send it over there, and the router washes its hand. That was me washing my hands. Wash, 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 wash. It's done. The PLAR extension dials 4300, sends it over to the IVR system, and the router is done with it. Meaning, if the IVR system is busy, or if the IVR system is, we'll say, out of commission, it just, rings on and rings on, it will be lost forever. I mean, the router's done. It's forwarded the call. It's done its job. But if you configure it for off-premise extension, what that means is, router, I want you to forward it down there, but I want you to watch it and make sure that it connects. Because if it doesn't connect, maybe we have some alternative method set up, meaning that it will fail over to another line or something if it doesn't connect. So pretty much, it's kind of like a transfer. You ever been transferred? I love it when I call into a company and I call up and I say, hi, this is my problem, da-da-da-da-da. And the person says, yeah, hang on, let me transfer you. But you know what? I'll stay on the phone line with you. And I'll explain your situation to the next person. You know why I love that? Because if I get disconnected or something like that, that person is there. They saw me get disconnected, and hopefully if they're good, they'll call me back. Or I don't have to worry about explaining my story twice. It's known as a supervised transfer, where somebody stays on with you during the call and explains the story to the next person before they drop off. Versus most companies, when you call up and you say, hey, this is my story, and they, oh, sorry, that's not my department. Let me transfer you over. This happens to me all the time with my cell phone. Let me transfer you over to the right person. And they transfer you over, and they're kind of like, wash. We're done with you. If you get dropped, oh well, you'll call back. You can tell I'm not passionate about this story. So in this case, using OPX is like the good person. Your router still watches the call to see if that IVR system picks up. So I'll exit out of that voice port, and I'll now go under the voice port 0/2/1. So if that one gets an incoming call, there's no DID number, so I'm going to just forward that down to 4300, the IVR system. As soon as that line now goes off hook on an incoming call, it will transfer it over to this IVR system and make sure that it gets through. Sweet. This router, I think, is pretty much configured now for local connectivity. Everything is grooving in this office. Now we need to configure it to connect to these off-site extensions over here using the WAN as our preferred link. That was one of our facts. The call should prefer to use the WAN connections if available. And if not, we need to use the PSTN. But we can't just send those extensions as 45XX. We should have 4-digit dialing everywhere. But if it uses the PSTN, we need to configure it to modify the number to do the DID range for that remote site, to hit that right range and configure it correctly. Wow, this sounds challenging. Let's go ahead and set up the voice over IP side first. So I'm going to hop onto my router, and I'm going to type in, I'm a little disoriented. Let's do a show dial peer voice summary. Just take a look at my dial plan. Okay, outbound, good. We've got our inbound, good. Local PBX, good. Local FXS, good. Let's go ahead and configure a dial peer. Let's say dial peer voice for the remote site 45XX extension. So let's just do 4500. And instead of being POTS, this is now voice over IP. And I'm going to say, going across the WAN link, the first thing I want to make sure of is that we're going to use the codec. And let's use the codec G.729. Let's go ahead and use Annex B, which also has the built-in voice activity detection, so it cuts out the moments of silence. So we've got our right codec configured. That wasn't given to us in our facts, but it sounds like a good practice to me. I'm going to go ahead and type in for our destination pattern 45 ... And for the remote site, I'm going to say session target will be IP version 4, TCP IP version 4 address of 10.15.1.1. Now we don't need to worry about any automatic digit stripping, because voice over IP peers never strip digits unless you want them to. So we're safe in this case. The destination pattern is good. So, wow, that was too easy, wasn't it? We've got, let's do a show dial peer voice summary. We've got our dial peer that is going to the remote site, IP version 4. Yeah, that's it. I mean, we've got our IP wide area network connection configured for that PBX. Of course, that PBX would need that POTS dial up here to pass it down here. But we're focused on this router to make sure we're okay. If something goes wrong, we can point the finger at that other administrator. We didn't like them anyway, so we can point our finger at them and be like, hey, it's their problem. So we now need to configure the redundancy. We need to say if the WAN is down, let's even make it better. Let's say if the WAN is not at a certain quality level, this is getting good, isn't it? Then we'll fail over and use our FXO ports. We'll use our PSTN connection to act as a backup. And not just one FXO port, but both of them. All right. Let's do it. I've got the dial peer configured, voice over IP. That's good to go. Let's go ahead and create a second dial peer. This will be 4501. This one will be our POTS dial peer. First thing I'm going to type, so I don't forget, is preference 1. And we'll say this goes to port 0/2/0. And the destination pattern is going to be 45 ... It's going to be an overlapping destination pattern with this one, but since it's a higher preference, it will only be used if this one is unavailable or below a certain quality level. We'll get to that in a moment. So we've got our destination pattern configured. Now, this is going out to the PSTN. It's going to automatically strip those digits. Yikes, not good. But also, if we, even if we do say 4 digits 4 and send that out to the PSTN, PSTN isn't going to get it. We've got to prefix the digits beforehand. Now, looking back at our fax sheet, this remote site has a DID range of 480.612.45XX. So here's what we need to do. We need to type in prefix and a string of digits, 480.612, and we can either say 45 and let the automatic digit strip take care of it, or we can type in 480.612, assuming this is a local, 10-digit dialing number. If it were long distance, we would have to put a 1 in front of that, but that's okay. We'll assume it's 10-digit, and we'll say 4 digits, and we'll put 10. So now, when it goes out to forward it, it will say, okay, destination pattern right there, prefix these digits, forward all 10 of them, should be good to go. Thinking, pondering, deep thought. No, that's good. All right, let's go down and let's set up our second one. Oh, I'm excited. I love doing real-world stuff. All right, 4502, preference 2. This is our secondary one now. If port 0/2/0 is unavailable, we'll go ahead and fail down to port 0/2/1, our second FXO port. Same destination pattern. 45 ... prefix 480.612 and 4 digits 10. All right, let's do a show dial peer voice summary. Oh, this is getting good. Look at it. We've got 45 ... That's our primary using the WAN connection. It's not going to strip any digits. 4-digit extensions are all right. Voice over IP dial peer. We've got the prefix digits over here. I love this output. Isn't this output great? Show dial peer voice summary. It shows you everything. You've got 4501, POTS dial peer, prefixing these digits on both of them. Same. We've got the preference 1, preference 2. Then whoosh, right over here, we've got our port 0/2/0, 0/2/1, both of them showing up. Good. Now, let me get this down and get our diagram back up into the picture. Now let's set it up to where it will fail over if we go below a certain quality level. Let's go ahead and do global config mode, and I'm going to do a call fallback. There we go. Call fallback. I'm going to say the threshold. And instead of configuring a specific delay and loss, packet loss, well, let's do it that way. ICPF is kind of the mysterious one where you kind of rely on the standards that be to say that the call was a good quality or so on. So, let's do it a little more specific with our Cisco recommended requirements. We'll say if the delay exceeds 150 milliseconds, you can see this is in terms of milliseconds, or our packet loss goes above 3%, I want to fail over. And before that failover will happen, I need to make sure I type in call fallback active to fall back to alternate dial peers. I'll type in active. And, oh, good. We already have it configured as active. Now I need to make sure I tell this router, this is the dial peer I'm talking about, dial peer 4500. If this one drops below the certain quality, let's go ahead and type in dial peer voice. I'll type in 4500. And I'll say this is the one that is going to be valid for call fallback. By typing that in, I've designated if this dial peer falls below these parameters I've defined in global config mode, then disable it and have it drop down to the secondary ones. Good. So we've got our SAA probe that's known as PSTN fallback. That's now configured. What else do we got to do? Oh, the facts. Let's go back there. Our fact sheet is telling us that remote site, local site, prefer to use the WAN, and voice over IP should be prioritized for up to 450 kilobits. Sounds like quality of service to me. So let's go ahead and set up quality of service to ensure that we get 450 kilobits per second of WAN bandwidth for our voice over IP traffic. Notice I emphasize voice over IP, the audio streams. So I'm going to go ahead and bring up the configuration. And the first thing I need to do is define a class map. I'll go ahead and say class map. Now remember, the class map is what matches our traffic. And we'll just say, well, we don't need to type match any or match all. The default is match all. And I'm only going to match one thing. I'm going to type in class map name, match voice. So I'll just name it. And underneath there, I'll say match protocol. This is using NBAR. And I'm going to type in, scroll, this one right here. O Sacred RTP, Real-Time Transport Protocol. That is our voice over IP stream that we're going to watch, and we're going to make sure that we catch that. So I type in match protocol RTP. You can see it paused because first time on this router loading up NBAR. That's the only thing I'm matching. So I'm going to create a policy map, and we'll say it, we'll name it, voice is good. And under the voice is good policy, I'm going to say for this policy, for the class, and we named it match voice. I'm going to say for this specific class, I want to grant priority bandwidth. You can see strict scheduling priority. Priority bandwidth for up to 450 kilobits per second. 450 kilobits per second. Now, the reason, and we can allow it to burst if we want to, but I'm not going to specify those parameters. You'll let the router figure all that out. By specifying 450 kilobits per second, notice it says strict priority. One of the big disadvantages of the old priority queuing mechanism, there used to be one called priority queuing, and it's still available, but it had no limit. Essentially, the prioritized traffic could jeopardize the rest of your network because they could eat however much bandwidth they wanted. When you specify it this way, it polices that 450 kilobits per second. Meaning, if you had a call try and go above that, it gets denied. The call will not be allowed through. And if you have your failover mechanism set up correctly, it can fail over down to the PSTN link when you run out of that priority bandwidth. That ensures that your voice doesn't jeopardize the wide area network for all the other types of network traffic that's crossing it. It's part of the whole Cisco Avid strategy. Now, the last thing I need to do is to apply that policy. I'll go under interface. The link that's connecting these two offices will be the serial 0/3/0 link, and I'm going to type in service policy output. Let me just make sure I'm not flying too fast. Output, and I will type in the policy name, voice is good. It is case sensitive. So I type in voice is good and hit enter. And now, oh, right. I have to type in no fair queue. The default queuing mechanism on any serial interface is known as weighted fair queuing, which means high volume senders do not crowd out low volume senders. For voice over IP, fair queuing is very bad because voice is a high volume sender. And fair queuing will say, oh, let me prioritize some data applications over your voice over IP. And that's not good. So now we'll put our voice is good service policy on the interface now that we've turned off weighted fair queuing. And if you decide to jump into the entire quality of service course, I'll show you a mechanism that you can use to keep weighted fair queuing for other traffic types other than voice, because voice always gets the priority. So now we've got that applied. I can type in show policy map and type in the interface serial 0/3/0, and now we can see that we have the match voice class map, which is matching all the RTP traffic, and as it comes through, these little counters will start ticking up. We can see that it has bandwidth of 450 kilobits per second, and the router will figure out how much of a burst that is. When you get into traffic shaping, again, this is all in the quality of service course, the burst is how much the router can burst on a given time interval, because the router will actually divide up every second into individual time slots, and it will squeeze 11,250 bytes per time slot to meet that 450 kilobits per second. You'll also be able to see if it's dropping any packets, if it's going above that 450 kilobits per second of priority bandwidth. Good. Good, good, good. Wow. That was intense. Are we done? I think so. I think that's it. We've got, this can act as our review here. We've got our FXS ports configured. Both of those assigned extensions. T1 CAS going to the PBX 43XX as our dial peer. IVR system is attached to that, so as long as we forward it down here, the PBX should be configured to handle that. FXO configured for outbound and inbound dialing to forward the extensions to the IVR system. Voice over IP dial peer for the WAN for the 45XX extensions, right? Let me just do a show dial peer voice summary. 45XX extensions shooting over to 10.15.1.1 over here. If that's down or the quality level isn't at what we define, which is a delay of 150 milliseconds or 3% packet loss, it will disable that link, disable that dial peer, and fail over to these higher precedence dial peers, going out the FXO ports 0/2/0 and /1. We've got our WAN configured now for quality of service to prioritize the voice. Ladies and gentlemen, we have a complete working voice over IP network. Yeah, I need a crowd sound effect right there. Yeah, isn't that awesome? That's it. I mean, wow. I'm amazed myself. I think that is it. That's fantastic. And that encompasses most of the concepts that we talked about going through this course in a very fly-by format. Well, I hope this has been informative for you, and I'd like to thank you for viewing.